Good afternoon, ladies and gentlemen. It has been a great pleasure and honor for us being a part of ICoDSE 2016 and presenting our work before such an intellectual community. Our work is about user interaction analysis to recommend suitable jobs in career-oriented social networking sites. At first, let us introduce the work to you. We know that career-oriented social networking sites are very much useful for job seekers to find a suitable job. This is also useful for recruiters to find the right candidate for a particular job. There are many such sites. For example, LinkedIn, Glaxo, Jobster, Craigslist, Zing has millions of users. Those sites generate millions of job postings daily, which is really big data. Thus, these sites must know where a user should apply and recommend only those job postings to that user. Now let us state the problem definition, which is basically this year's SEM recommender system known as RICSYS challenge. Given a user, the goal of the job recommendation system is to predict those job postings that are likely to be relevant to that user. Here, relevant means a user will positively interact with that is click, bookmark, apply for job, or reply to recruiters, or may delete shown job recommendations. So what is our motivation behind the work? Of course, job recommendation system helps job seekers to find appropriate jobs matching with their entire profile. Thus, job recommendation system is considered as recruiters approaching a suitable candidate whenever there have been a appropriate job for them. Indeed, this saves a lot of time and effort on the job seeker's side, and they get matched to more appropriate positions online. Now let's look at some of related works. First one is the browse maps, collaborative filtering at LinkedIn. Here a hybrid of offline-online system has been proposed which computes a latent co-occurrence graph in batch and serves results to users with low latency. Various datasets which job and profile browse maps produces are also used in many hybrid recommendation systems that combine collaborative filtering and content-based matching. They have presented lessons learned in the field over several years from case studies on how LinkedIn uses the browse map platform. But there is no explanation about showing similar jobs. It performs content-based matching of the job posting based on title, description, required skills, and location similarity. Recommended systems can be augmented with more sophisticated similarity rankers using browse map. Data elements as latent features such as co-occurrences of views, follows, like, comments, searches, and so on. Here, no description about the dataset as well. Second one is Metaphor, a system for related search recommendations. They proposed 4 main signals, building the recommendation dataset for Metaphor. One signal is based on collaborative filtering and analyzes what members search for together based on temporal proximity. Another signal takes advantage of search personalization in the social network to derive relationships based on clicks. Additional signals look at partial matches among queries and the length differential between queries and suggestions for modeling click behavior. But it does not incorporate and evaluate a user feedback loop for displayed suggestions. A feedback loop can be useful because it allows to experiment with new recommendations that would not otherwise have made it to the top end suggestions displayed to the user. Moreover, it does not work yet on personalizing related searches based on member searches and profiles, much like the core search experience that provides personalized results to members, and no description about dataset as well in this work. Another one is recommended system for job seeking and recruiting website. This hybrid recommendation system exploits job and user profiles and actions undertaken by users to generate personalized recommendations of candidates and jobs. Data collected from the website is modeled using a directed, weighted, and multi-relational graph, and the 3A ranking algorithm is exploited to rank items according to their relevance to the target user. But here, a preliminary evaluation is conducted based on simulated data and production data from a job hunting website in Switzerland. User studies and evaluations based on online data should be conducted to evaluate the accuracy, usability, and other characteristics of the proposed recommender system. Here, no descriptions about the dataset as well, only interrelations of entities are stated. Matching people and jobs, a bilateral recommendation approach, personalized contextual and relational based recommender system, automated collaborative filtering applications for online recruitment services are some other mentionable works. Now, how our approach is different from state of the art. Here, we have handled big data set of zinc which is publicly available, where anonymization, pseudonymization, noise were present. We have considered all possible factors related to users as well job items available in the given dataset for job recommendation system. We have demonstrated performance comparison of our proposed approaches of job recommendation system. Here is the data analysis part. Training dataset of Zinc contains 4 entities, which are impressions, interactions, user, and items. Impression data contains user ID, year, week of the year items, which is about 7.81 GB in size. Interactions data contains user ID, item ID, interaction type, timestamp, which is 237 MB in size. Here, interaction type has 4 categories, which are clicked, bookmarked, clicked, reply or apply, delete, or recommendation. Again, user contains user ID, present job role, discipline ID, industry ID, country and region experience numbers, experience years in total, experience years current, education degree, education field of studies, career level, etc. Where there are 6 categories of career level and 4 categories of education degrees. Total size of CSV file is 60.2 MB. Last of all, item consists of item ID, title, discipline ID, industry ID, country code, region, latitude, longitude, tax, timestamp, career level, active during test, employment type. Here, career level has 6 categories. 0 denotes not active anymore, and 1 means active, that is recommendable in another attribute. And employment type is of 6 types. Now, in the data pre-processing step, at first, we have eliminated all the null or missing values from the dataset. Then we have analyzed the dataset and found that although the file was given as comma-separated format, it was actually space-separated values present in the dataset. So we have deployed our code considering this fact, and after rigorous pre-processing of the Zinc dataset for developing job recommender system. The solution approach. The training dataset is intended for experimenting and training the proposed models. We have split the interaction data into training and test data for the purpose of evaluating our proposed algorithms during development. For example, we left out the last complete week of the year from the interaction data and then try to predict whether a given user will positively interact with an item within that week. Relevant items are those items on which a user clicked, bookmarked, or replied. Initially, our approach has been to deploy user-user collaborative filtering algorithm for designing job recommender system. Then we have computed item-item similarity to improve the results. After that, we have combined both the approaches and made it hybrid to compute efficiently and build the proposed job recommender system more faster and accurate. In this approach, as illustrated in this figure, we have computed a weighted score from the prior information of user interaction and users relevant data for a particular user. In the meantime, we have computed weighted score for a user from given information of a target user based on user interactions and user profile. After that, we have calculated user-user similarity between weighted scores using mean squared deviation similarity metric. Then we have calculated top n similar jobs for the test user using collaborative filtering algorithm. From that, we have recommended top n similar users. Finally, list of jobs to target user has been given. As you can see, the entire flow is illustrated here. In the item-item approach, we have computed a weighted score from the prior information of user interaction and users' relevant data for a particular job item. In the meantime, we have computed a weighted score for an item that is job from given information of our target user based on user interactions and user profile. After that, we have calculated item-item similarity between weighted scores using mean square deviation similarity metric. Then we have calculated top n similar jobs for the test user using collaborative filtering algorithm. From that, we have recommended top n similar jobs. Finally, list of jobs to target user has been provided as the entire flow is depicted in this flowchart. For more accurate computation, we have combined both the user-user and item-item collaborative approach and developed the job recommender system using the dataset of Zing. First of all, we have calculated item-item as well as user-user similarity and then select top n similar items from impression data and top m similar users for our user. After that, we have predicted top p items from top n similar items as well as top q items from top m similar users. Then we have calculated the intersection between user-user and item-item based recommended list and selected top k items as recommended list. On the other hand, we have selected top 30 items from last week as our recommended list for each user. Then we have compared the predicted recommended list with the actual list. Finally, we have evaluated the recommended system accuracy. And the algorithm of hybrid approach is demonstrated in this slide. Now let's look at the experimental setup part. We have split the dataset using the algorithm, dataset splitting using the training dataset of impression data and interaction data and certain percentage of split of the testing data. We can see the dataset splitting algorithm here. Here is the implementation details part. We have used Java language, Windows environment and NetBeans IDE 802. Dataset is Zing dataset which contains 5 CSV files. We have split the target users files into 15 separate chunks where 10,000 users per chunk and run the code separately with them. Here is the algorithm for target users splitting. After running the Java project in several personal local computers, we have gathered all the separate solution files and merged them to form the main solution of 150,000 target users for each of the approaches. Please have a look at the code snippets. Here is the code, how we have loaded the data. Here is the code snippet of how we have calculated the score. And finally, how top 30 relevant jobs are recommended. Now let's discuss about the experimental results. After getting the output from separate chunk, we have merged the solution file for total target users. Here you can see the system information and snapshot of the output obtained. Here is another system information. As we have run the code in Java language on several local personal computers for powerful computation. Here you can see the snapshot of getting output from several PCs and merging all solution file to get main solution file. Now experimental evaluation. We have divided the dataset into test, train, split to get much more score compared to the score that we get from the online evaluation. To obtain a score, we use the score calculation algorithm provided by the RICSYS 2016 official website for further offline evaluation. After splitting the data of recent week interactions for test data, we train our model using the train data and predict the items for the most recent week interaction and evaluated the main solution file for all target users. The algorithm can therefore exploit all the training data. The quality of the recommendations was measured, which was generated by proposed algorithm for each of the target users based on the scoring function SCORE-ST provided by the official website of RICSYS Challenge. Here is the Python code snippet for calculating the score for each of the proposed approaches for the job recommender system. Here is the code snippets of how we have obtained the last week data for testing. And here is the obtained data for testing purpose. Here is the results comparison. For each of the cases of user, item, and hybrid approach, we have generated scores using the offline score calculation algorithm for different sparsity. Then we have plotted scores against sparsity of training data in graphs for 3 different approaches. Finally, we have analyzed from graph for user computation, for item computation, and for hybrid computation. It has been observed that for sparsity from 30 to 90% of the training data, obtained score in user approach is almost doubled in item approach. Again, in case of hybrid approach, obtained score is very high for the entire sparsity of 10% to 90% of the training data compared to the other 2 approaches. The rate of increasing scores in case of hybrid approach is almost 2.5 times than item approach. Thus, we can conclude that the hybrid of user and item approach performs better than the separate 2 approaches for our proposed job recommendation system. So, our proposed job recommendation system can predict job postings according to rank list that are likely to be more relevant to the user of given Zing dataset. For offline evaluation, we have calculated score using given algorithm and shown comparison of scores against the sparsity of the dataset. So, if we get much more information about the users, we get much better chance to predict accurately using our proposed job recommender system. That's all. Thank you all for listening with patience. If you have any question or suggestion, please feel free to contact with us. Here's our email addresses. Thank you again.